This is Unit 2, Section 1, and we're going to talk about transformations in the coordinate plane today. First, I want to show you guys the calendar. Please notice that on Wednesday we're having a quiz, and on Friday we're having a quiz. We're going to cover 2 sections quiz, 2 sections quiz. We don't have any school on Monday. Have one more section to, well, it's sort of a section, but it's basically pulling all the pieces together. Next week, and then we're going to have our test next Friday. So really 9 days and we're going to be through with this unit. These are our I can statements. I can describe and compare function transformations. I can represent and compare rigid and size transformations of figures in a coordinate plane. I can compare transformations, describe rotations and reflections, and I can transform a figure given a rotation, translation, or reflection. So the first thing we're going to do is go over these terms. A transformation is a change in the position, size, or shape of a figure. The original figure is called the preimage. The resulting figure is called an image. And a transformation maps the preimage to the image. It's really important that you guys remember preimage is what happened before, and pre obviously means before. When we're talking about arrow notation, it's used to describe a transformation, and the primes are used to label the image when there's nothing attached. So you notice this XYZ right here has no primes. That is the preimage, and then the XYZ prime is the image. So this is an example of a preimage and an image, and you notice that our preimage is ABC and our image is ABC prime, and that this image moved to the right and down. So that's what's represented here. So let's talk about reflection. So a reflection or flip, and I think it's really important that you guys key in on this word flip, because that's what you're going to see when you see reflections. It's a transformation across a line called the line of reflection. Each point in this image are the same distance from the line of reflection. So if we look at one of these with an XY plane, so we got, or an XY coordinate, sorry. So let's just draw us a little triangle up here and call this A, B, C. So if we were talking about a reflection, say, across the x-axis, so reflect across x-axis. So that means that everything that was close to the x-axis is going to stay close to the x-axis, and everything that was far away from the x-axis is going to stay far away. So we got our A and our B here. So this would be A prime and B prime. And then we would still have our C down here. And I guess I drew that a little bit bigger, but that's okay. You guys get the idea. So notice again that our A and our A prime are close to the x-axis. Our B and our B prime are close to the x-axis, whereas the C and the C prime are further away. That's one of the ways that you can tell that it's a reflection. Things didn't stay the same way they were originally, with A and B at the bottom and C at the top. Now we have A and B at the top and C at the bottom. That's one of the signs or symptoms to us that that is a reflection. Our next one we want to talk about is a rotation. So, come on, mouse. All right, so let's go backwards. So let's talk about a rotation now. A rotation or turn. So when we talk about a rotation, we're again going to talk about a transformation that's about a point called the center of rotation. Now I'm going to do one that's going to rotate from the origin, which is the at 0, 0. So we're going to rotate around this point right here. Again, I'm going to draw us a triangle up here, and I'm going to call it ABC. And this time I'm going to rotate it 90 degrees to the left, with its center of rotation again being the origin. So when I do this, we're going to end up with A prime, B prime, and C prime. Now I want you to notice, we're just going to look at one side of this. So let's just look at our AC right here. Notice this AC. Let's look over here where the AC went. So if you notice, it went from being vertical to horizontal, and it turned 90 degrees to the left. So I want to also bring to your attention that that's quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And each of these represents a 90-degree change. So when I go from here to here, that's 90 degrees. If I was to continue around down to here, this would be 180 degrees. And continuing on, this would be 270. Obviously, if we went all the way back to where we began, that would be 360 degrees. So those are the rotations. And when we talk about rotations, a normal rotation is counterclockwise, and that's because the numbers are ordered that way, 1, 2, 3, 4, going counterclockwise. So most rotations are going to just say rotate 90 degrees. If it says clockwise, you're going to go to the right, whereas normal rotations are going to go to the left. That's a counterclockwise direction. Our third one's a translation or a slide. This is a transformation in which all the points of the figure move the same distance in the same direction. So if you notice here in our transformation, we're moving up and to the right. Notice also that our J remains top left. See that? Our M is top right, our K is bottom left, and our L is bottom right. The position of the letters is not going to change when we're doing a translation. So it's another one of those hints that you can look for in a drawing to determine if it's a translation. So on this one, 1A, it says identify the transformation, then use the arrow notation to describe the transformation. So on this one, again, I want you to notice, if we look at our original, let's just look at this one right here, BC, and I'm using that one because it's vertical, it's easier to see. I'm sorry, AB, and there's our AB there. So again, we should be able to see that this went from being vertical to horizontal. So this is a 90-degree rotation. The transformation can't be a reflection because each point in its image are not the same direction from the line of reflection. Now this one here, this is, notice here we got one away here and one above and one below, one above, one below. This is two above, two below, two above E, and two below E. So this is going to be, sorry, a reflection over the x-axis. The transformation can't be a translation because each of the points in the image are not in the same relative position. If it was a translation, the D and E would have stayed on the top instead of going to the bottom. So this is a reflection over x-axis. And again, when we talk about our translation, we're going to say DEF translates to DEF prime. Sorry, DEFG prime. So go ahead and figure these two out and then come back to me. So we're going to identify each transformation and use arrow notation to describe the transformation. So I noticed that we're going from, first of all, I noticed that none of the letter orientation changes. So M is top left, P is top right, N is bottom left, and O is bottom right. So this is going to be a translation. So the question is, how did it translate? Well, I notice it's translating to the right and down. So that's what we're going to say. Now we don't know how much because it's not on a grid, but that was the translation. So MNOP translates to be MNOP prime. Number 2 over here, I do notice here that this shape is no longer oriented the way it was originally. So again, we're going to look at some of the sides here, see if we can compare. And I'm going to compare a vertical side. So we've got our ZY here, and then we've got our ZY there. Notice again that it's a 90-degree turn. So if I turn that straight line 90 degrees to the left, which would be counterclockwise, then it would be a 90-degree rotation. So once again, we are rotating triangle XYZ to triangle XYZ prime. So this next one is not in your notes, but I'm going to go over it with you anyway. It says identify each transformation, then use the arrow notation to describe the transformation. This one we should be able to see as a reflection over a vertical line. So our C and C prime are close to that line. Our A and A prime are further away, and so is B and B prime. So this is a reflection across a vertical line. So ABC translates to ABC prime. Go ahead and plot these vertices A, B, and C and A, B, and C prime, and make sure that when you do so that you label them A, B, and C, and A, B, and C prime. So once you've done that, you should have this image. So you should be able to see pretty quickly that if we've got this line right here, A is 1 to the right and 1 to the left of that line, B is 2 to the right, B prime is 2 to the left, C is 4 to the right and 4 to the left. So again, this is a reflection. We should be able to see that, and it's going to be a reflection over the y-axis. Last one, go ahead and plot these points again, EFGH, a quadrilateral, and EFGH prime. Come back to me when you're done. So this one, we see again that we have EFGH down here on the bottom. And again, I'm going to take one of these sides. This I immediately noticed it's not oriented the same way because it was wider than it was tall, and now it's taller than it was wide. So that's the first thing I noticed, but I'm going to go ahead and look at this EH here, and EH goes there. So once again, I noticed that it turns 90 degrees to the left. That would be counterclockwise. That's a normal rotation. So this is going to be a 90-degree rotation. That's the type of transformation it is.